Okay, a 1 mole sample of an ideal gas is kept at 0 degrees Celsius, okay, during expansion from 3 liter to 10 liter. Okay, how much work is done on the gas during expansion? Okay, so here we have number of mole. Okay, kept at. He said kept at 0 degrees Celsius. That means this temperature. This is the temperature, and it must be constant during this process of expansion from 3 liter to 10 liter. So this kept at this temperature. So this is we can say this is an isothermal expansion. This is a isothermal expansion. Yeah, temperature is kept constant. Isothermal expansion. And then be careful with the unit. This one is 0 degrees Celsius. You have to change to Kelvin. SI unit. SI unit always. Also, this one is in liter form. You have to change to meter cube. SI unit. Okay. 3 liter to 10 liter. So how much work is done? So the question asks for work done, okay, during this isothermal expansion. Okay, so how to do? Okay, so for isothermal process, let's look at the isothermal process. Isothermal process, to find the work done is this one. Work done equal to nRT ln V2 over V1, or V final over V initial. This formula. Okay. Question A, this is isothermal expansion, yeah, isothermal process. So to find the work done, we use the formula nRT ln V2 over V1. Okay, ln V2 over V1. This is actually V final over V initial. So which one is V final? This one is V final. This one is V initial. Okay. 3 liter is V initial. V final is 10 liter. Okay. So okay, we can do it. Temperature we have to change to Kelvin. So let's find the temperature in Kelvin first. 0 degrees Celsius. So it's 273 Kelvin. Okay. And then the volume, okay, but in fact this is a ratio. Yeah, you divide, the liter is already been cancelled. Yeah, so okay, this one no need to change to because volume divided by volume, the unit is being cancelled, so you can maintain as liter lah. Okay, so okay, number of mole. Okay, number of mole is 1. And then R is 8.31, and then temperature is 273 Kelvin. Remember, it must be Kelvin unit. Ln V2, V2 is V final, which is the 10 liter. Okay, divided by V1. V1 is V initial, 3 liter. Okay, so the unit is being cancelled. So what's the answer? We can get the answer already. Yeah. Okay, so the answer is 2731.37 joule. Yeah, is that correct? 2731. Yes, exponent 3. That's correct. Okay. Now, if the gas is returned to original volume by means of isobaric process, this time is an isobaric process, how much work is done on the gas? So this question also asks for work done, and it is isobaric process. Okay, now it's isobaric process. Return to original volume. Return to original volume. Okay, maybe we can describe this in a graph. Yeah, maybe you draw a graph to understand what's happening. Okay, this is a pressure volume graph. I'm trying to draw a pressure volume graph. Pressure volume. Okay, so from this in liter, from 3 liter to 10 liter. Okay, so isothermal expansion. Isothermal expansion means you follow the isothermal line. You follow isothermal line like that. Yeah. So okay, so if from here go to here, that means the graph is actually this one, isothermal expansion. Okay, it's isothermal expansion. Isothermal expansion. So okay, 3 liter to 10 liter. So this isotherm line, the temperature is kept at 0 degrees Celsius. So we can say this they have the same temperature. All of is always 0 degrees Celsius. Yeah, this temperature is 0 degrees Celsius or 273 Kelvin. Okay, isotherm line. And then for so just now question A, find the work done during the expansion means we find the area under the graph. This area, understand? Just now this 2731 is this area. Okay, is this area. Okay, now question B, he say return to original volume by isobaric process. Okay, let's wrap this off. Okay, so for question B, it start from this point. Okay, this point. Return to original volume. That means it go from 10 liter, go back to 3 liter. Isobaric means constant pressure. Constant pressure. So it maintain the same pressure. Okay, last time had different pressure. This time is this pressure. So it maintain at this pressure. I don't know what pressure is that. But it maintain as same pressure because isobaric. Yeah, he returned to original volume. Original volume is actually 3 liter. Okay, so it go back from 10 liter to 3 liter using isobaric process at constant pressure. So this is the graph. Understand? From 10 liter go back to 3 liter. Isobaric maintains same pressure. So this is isobaric process. Go back to here. Okay, but this one at different temperature already, not 0 degrees Celsius anymore. It is at different isotherm line. You understand? At lower temperature already, I can say it is at the lower. It should be less than 0 degrees Celsius, less than 273 Kelvin, because this isotherm line now is nearer to the axis. Remember when I say about this one, when the isotherm line getting far and far away from the T and pressure and volume axis, get the isotherm line getting far and far away, the temperature increase from you see like this one, 300, 400, 500, temperature increase. Temperature increase. So the isotherm line nearer to the axis is at lower temperature. The isotherm line at further away is at higher temperature. So we can see this one. The B part B isobaric process go back to the original volume, 3 liter. It actually go down to a lower temperature, lower isotherm line, which is nearer to the PV axis. Okay, so this one has a lower temperature. Yeah, has a lower temperature. What I can say is maybe I can put this one as T1, this one as T2. It is less than T1. Yeah, it go back to a lower temperature. Okay, so now let's find out how much work is done on the gas. That means this question B, want to find work done. So work done is area under the graph, right? But this is work done for the isobaric process only. Work done for the isobaric process. That means area under this horizontal line. So which is this one? So we want to find the area under isobaric process. So how to find this area? How? So isobaric process is a rectangular shape. Isobaric process. Let's look at isobaric process. Isobaric process is rectangular shape, is W equal to P delta V. P delta V, pressure multiply change of volume, or V final minus V initial. Like isothermal process is a curved line. It's a curved line, so we have a special formula for it. nRT ln V2 over V1. That's isothermal work done. For adiabatic, for isobaric work done is simpler. Just pressure multiply change of volume. P delta V. Okay, or V final minus V initial. Okay, so let's find out. Let's do it. So for question B, I want to find it's a isobaric process. Never mind, just put it over here. Okay. So I want to find the work done now is using P delta V. Pressure multiply change of volume. P delta V. So which is pressure V final minus V initial. So which one is V final? Which one is V initial? Look at the arrow. The arrow. He say return to original volume. Return to original volume. So this is V final. This 3 liter is V final. Initial is 10 liter. Understand? So for isobaric process, 3 liter is V final. 10 liter is V initial. Okay? So this is a V final. This is V initial for isobaric process. But for isothermal process, 10 liter is V final. For isothermal process, 10 liter is V final. But for isobaric process, the 3 liter is V final. So it's different. You must look at the arrow. The arrow from where to where. For isobaric process, the arrow is to the left. To the left. The isothermal process, the arrow is to the right. So it's different. Opposite. Okay. So for isobaric process, the arrow is to the left. To the left. So 3 liter is V final. 10 liter is V initial. So this one we should use V final minus V initial, or sometimes we just write as a P V2 minus V1. Understand? So okay, makes sense. Okay, so now we need to find the pressure. We don't have the pressure yet, isn't it? So we need to find this pressure. So how going to find this pressure? So we can use PV equal to nRT to find the pressure. So we can actually, we can either use which point? We want to find the pressure. We want to find which pressure. Is it this pressure 1 or this pressure 2? Which one? Pressure 1 or pressure 2? Of course, pressure 2. Yeah, this point. Yeah, maintain at same pressure. Okay, so we're going to find this pressure at this point. Pressure at this point. So which is P2. We're going to use this pressure. Just PV equal to nRT lah. Just never mind. Just put PV equal to nRT. Going to find this pressure at here. PV equal to nRT. So I want to ask you, what is the volume at this point? 10 liter. Okay. We can substitute this one. You see, you have a graph. Then easy. When you solve this question, it becomes easier once you have the graph. If you don't have the graph, you very hard to imagine. Very hard to imagine what's happening. We don't know. We want to use the 3 liter or the 10 liter to find the pressure. You see that? So this one we use the 10 liter. 10 liter to find the pressure. Because the 10 liter one is the point here, which has the same pressure as this point. See that? So use the 10 liter. This one must use 10 liter. The number of mole is 1 mole. You see that? 1 mole. 1 mole. And then temperature is 0 degrees Celsius. Is T1. 0 degrees Celsius or 273 Kelvin. We don't know the temperature here. We don't know the temperature T2 here, but we know T1. Understand? We know everything about this point. So this one is the 0 degrees Celsius, which is you must change to Kelvin. You cannot use degrees Celsius. Understand? So okay, so let's find out pressure here. Let's find out pressure here. So okay, so pressure. So pressure volume is 10 liter. You have to change to SI unit. 10 liter is 10 dm cube because 1 liter is actually 1 dm cube. You know that 1 liter is 1 dm cube. So 10 liter is 10 dm cube, which is the 10 deci is negative 1. Negative 1 exponent 3 become negative 3. Okay. So, okay, this is a 10 exponent negative 3 meter cube. Must change to SI unit. Okay. Many students wrong because they didn't change the liter to meter cube. Everything must be in SI unit. Okay. So, all right. So, 1 mole. This is 1 mole. R is 8.31. Temperature is 273 Kelvin. 273 Kelvin. Okay, so all in SI unit. So now, okay, find the pressure here. So what's the pressure? The pressure. Okay, so the pressure is 226863 Pascal. Also SI unit. So we got the pressure already. Pressure at this point. Yeah. We want to find pressure at this point. Not pressure at this point. Because at here is different pressure. This here is different pressure. This one over here you become over this point. The volume is 3 liter. So temperature is also 273 Kelvin, 0 degrees Celsius. So pressure is different. Yeah, this P1 is different. You also can find the pressure over here using 3 liter. But it is a higher temperature, higher pressure. P1 is higher pressure than P2. But we don't care about this pressure here. If you want to find pressure here, you can use the 3 liter temperature, this one, and find the pressure PV equal to nRT to find the pressure here. But we don't want. We want to find the pressure here because for isobaric process start from here, not start from here. Understand? Isobaric process start from here. So that's why you must draw a graph. Then it's easier for you to see. Yeah. Then if not, you don't know what's happening here. Okay. So isobaric process start from here. So it isobaric process maintain at same pressure at this point. So we need to find pressure over here. Okay, the pressure over here is using volume 10 liter and temperature 0 degrees Celsius. So we can find pressure here. And then when it compress isobarically, then become volume 3 liter. This one has lower temperature already, not the 0 degrees Celsius. Become lower than 0 degrees Celsius. Okay. Okay, so we already accomplished. We already find the pressure over here, which is this one, this value. So when it compressed from 10 liter to 3 liter, it maintained at this pressure. Maintain at this pressure, constant pressure, isobaric. Yeah, maintain at this pressure. So okay, so we got the pressure already. So this value here is I can just write over here. You see, I can just write over here. The pressure over here is 226863 Pascal. Is helpful for us. Once we draw the things in the diagram, then it's easy for us to see. So how to find the area under this isobaric process? Just use this pressure multiplied by the change of volume. And it must be V final minus V initial because the arrow is to the left, not to the right. The arrow is to the left. Arrow is to the left. So 3 liter is V final. You must use 3 minus 10, not 10 minus 3. Okay? Let's do it. So this is pressure. Just now we got it. Maintain as constant pressure, compression. Yeah, this is in Pascal. V final is 3 liter. Oh, again, this one you have to change to. This is the SI unit. 3 dm cube. Yeah. This one is 10 dm cube. You have to change to SI unit because the SI unit of work done is joule. So this one you cannot maintain at liter. You must put in dm cube. Okay, so you can actually just write 3 minus 10, but then here because it's decimeter cube, so exponent -1, exponent -1, power 3 become exponent -3. So here you can just put exponent -3 meter cube. Yeah, I factor out already. I factor out this exponent from the 3 and 10. I factor out this one. So then your calculation seems not so messy lah. Okay, so calculate the work done. Now calculate the work done. So multiply by, okay, calculate the work done and see whether we get the answer or not. Okay, exponent -3. Okay, and the answer is negative 1588, negative 1588.041 joule. Is it correct? Is it correct? Negative 1588, yeah, negative 1.59 exponent 3. That's correct. 1.88 exponent 1.59 exponent 3. That's correct. And it's negative value. You see that? So it's negative work done. Okay, so it's correct lah. This answer is correct. Just now, this one is positive value. You see that? This one is positive value. This one and for this one is a negative value. Why? Why is it this positive? And why is it this positive and this one negative? Because this one is isothermal expansion. This one is just now the first process is isothermal expansion. The graph go to the right. The graph go to the right. Expansion. Volume increase. Work done by the gas. Because of expansion. That's why positive work done. This is work done. Work by gas. It's work by gas. Expansion. Because volume increase. Okay, work done by gas or work done by system. Okay, this one is negative because why? Because this is a isobaric compression. Yeah, isobaric compression because it returned to original volume, returned from 10 liter to 3 liter. So it's compression. So it's work done on gas. This one is work done on gas. That means you compress the gas. The gas don't compress themselves. You compress the gas. You work done on the gas. The gas doesn't do any work. The gas doesn't do any work. So that's why negative work done. Okay. So this compression. Because volume decrease. Volume decrease, you usually get a negative work done. Okay, so that's all for these questions. I hope you understand my lengthy explanation. Okay, bye.